This is Professor Robert Needing, and I'm back with using Desmos in Math 168. Let's talk about calculator inputs. Well, first of all, there's a wonderful list of commands that are available, and you can get to those commands for Desmos by finding the tiny URL that I have right here. So take a moment if you need to and snap that in. And where that'll take you to is the Desmos screen, which allows you to look at any function that's available. Anything from trigonometry to linear functions to basic parabolas to max, min, statistical values. And you'll see all the stat functions. So under stat functions, we have a lot of things. Totaling, minimum, maximum. We used many of these number of elements, standard deviations. But students often get confused with where things are and they forget how to do things. Like, for instance, when I'm making a list, remember it's a equal, it's some kind of value. It always has to be in a bracket. It's 1, comma 2, comma 3, and it's enter. There's my list. And then you can call up totals of lists. And call up a total list, and total list in A it just happens to be 6. Okay, but when we start to get to other functions, like for instance, the normal distribution, is it normal distribution? Is it distribution normal? Which one is it? And if I get lost, let's say I get lost, it's not coming up. You see, it's not changing. Well, the way to fix that, in case you get lost, is to go down here to where it says functions. And under functions, there's trigonometry, statistics, distribution, and there's a miscellaneous one also. So the stats one is probably a great place to look at when you're looking for doing operations on numbers. So if you want the mean value or the standard deviation, here's the standard deviation. I want the standard deviation of A. I just simply get it. The standard deviation of this value is A equals 1. Now if I go back to that function again, let's grab something else. Let's take the standard deviation population. Wow, that's a different number, isn't it? A and equals, notice they're not the same. When we talk in stats class about standard deviation of a statistic, or a sample versus a population, they do not return exactly the same number. What else is in function? Well, we have all these different things: length, mean, max, min, quartiles. We've used stats before, and if we use the stats for A right now, we would get all of the 5 number summary. But I like the one also, especially for when we're talking about distribution. Here's your histograms, your dot plots, and your box plots. So if you wanted to run a histogram, box plot, or dox plot on this data, you could simply run a box plot, run a box plot of A. You could say enter. Remember the cool little feature here, the little zoom fit, and the zoom fit will give you your box plot of A and exclude all errors. But because I've got 3 elements, it's not working so well. So I'm going to add some more numbers in here. I'm going to put in a 10, a 12, an 18, a 19, and a 25. Now I'm going to go back down to my box plot. I'm going to hit my little zoom. And my zoom, oops, right here. Hit my little zoom data. And it's right there. So I get a nice box plot. What else do I have under functions? Well, I can do a box plot. I can do a dot plot and histogram. But over here are my distributions. Like for instance, my normal distribution. Normal distribution is something we use often. A normal distribution, I'm going to turn off box plot, is always put on a 0, comma 1, no matter what. I didn't turn off my box plot. There we go. I always like to put a 0, comma 1 in there just to know that's what I'm dealing with. And if you want the cumulative probability or the CDF function, you simply just hit the CDF for the display and it will give that to you right there. You can change the color, of course, by clicking, holding, and changing color. One more function is probably the inverse CDF. Now, when using the inverse CDF, you have to give a couple parameters here, and I'm gonna walk you through before I do it what it is. So first of all, in an inverse CDF, and I'm gonna get rid of all this other stuff up here because I don't need any of this stuff. It can all go away so that our lists are a little bit tighter to where we're, and get rid of the list there. So what does an inverse CDF have to have? An inverse CDL is, first of all, it's looking for an endpoint. That's what it wants of a distribution. Well, there's some parameters that we have to give that distribution, and I can't type, as you can obviously see. At least I'm consistent on my poor typing skills. What else do I have to have? Okay, well, I got to have 2 things. One, I have to have the mu value or the center of the curve. Center of the curve has to have some kind of standard deviation. And then Additionally, after that, after I give those values, and those values will be inside of a set of parentheses, then I'm going to have to give it some kind of area to the left. And I'll give you an example. So let's say that I have a normal distribution of zero point 0.1 right here, and it's already normally distributed on 0, 1. And I want to find the endpoints which give me something about this normal distribution. Well, either I can copy this normal distribution 0, 1 like this, say, control copy. I want to do an inverse on you. I don't have a normal distribution already, and I always recommend you start with a normal distribution and then go to an inverse. I could also be right here, and I could go back to function. I could go back to and grab the distribution. I could grab the normal distribution. I could type 0, comma 1. That seems like a little too much work to me. Now, in addition to that, though, I have to remember, though, okay, I got to end this parenthesis, and now I got to tear the area to the left. Okay, what area do I want to have to the left? Let's just say that I want to have, first of all, I have to have a comma, because there's a comma between it. And remember, it's always a decimal between 0 and 1. So let's say I want 50%. Well, it tells me that your z-score or your critical score or your endpoint would be 0. If I put a maximum in here of 0, notice I get 50%. Hey, it works. Okay, well, let's remember 2.5% to the left, a tail is somewhere around having a negative 2 z-score. So let's try that. So let's go up here to the area and let's change this to, first of all, it's left hand side. 2.5% is 0.025. I have too many decimals, as you can see, so it won't work. Back at the z-score, negative 955, negative 5, 9, negative 1.96. So if I go over here and I say, you know what, I want a minimum of infinity, and I want, and the way you get infinity is just click in there and then you just click anywhere else and it goes back to infinity negative. I want a negative 1.96. Look how close that is to negative 2. So my 2.5% tail is out over this direction. Now, if I wanted to also at the same time do the right hand side tail, well, remember these things are symmetrical. So over here is a 196 on the opposite side. So if I said my minimum number was 1.96, and my maximum number, again, I made it, highlight it, get rid of it, just click outside of it, and there's my 2 value over here. I have, again, about 2.5% on the right hand side. Watch where your statistics come from. Use your function as much as possible. Most of the things we do in here will be the normal, the t distribution, and the inverse CDF. There's also a random function on here too that you can mess around for randomizing different values. Hope it helps you. Let me know if you have any questions.